Okay, hi everyone. So in this run through, I'm going to go through this Lab 10 script. Now, this is more or less exactly the same as what we went through on the Lab 8 script, in that it is a description of a data set and a code book and a series of questions. And as we talked about, this mirrors the final assessment. In this case, the first section of this is what we call data wrangling. So this is what I spent quite a bit of time talking about in the last run through. And so this time, actually, we're just going to skip through all of this and we're going to deal with part 2 on distributions. This is what took up most of the labs this week. And then I'm also going to go through these questions on bivariate analyses, all of which involves some code that we've already done, but it's useful to go over it again in the context of kind of answering questions. So I've got this loaded up here in our studio. This is the Lab 10 script, and I've also got my cheat sheets to refer to if I need to. So this is using new data. So this is BSA Teaching 2019 CSV. And the description of the data set here tells you what this is. So the BSA is actually, this is another real data set, and it's pretty widely used in political science and sociology and a few other fields as well. One of the reasons is because this has been running since 1983. So we have some very long-running data on all the stuff in here. Now, this is just 1 year, and it's only a selection of the questions. But nonetheless, this is a data set that you might encounter again, either in reading or when some of you were doing quantitative dissertations at some point. First thing I'm going to do is I am going to just make sure that I've got my working directory set correctly. So I'm going to choose directory. I'm going to come over here. Where am I teaching? Intro to social data. I think I've got this here in 2025. So let's open that up. So I've set my working directory there, and I'm going to load in the data. So we've got 3,224 observations, 11 variables. Now, as I said, I'm going to skip over these questions. This is a lot of similar stuff that we dealt with last time. So it's things like using if, else, and case when to recode our data a bit, creating some factor variables. We'll actually come back to that in a little bit. But one interesting thing that we've got in this script is that here we have all of questions 1 to 4 done in one block of code. So what you can see here is we've got BSA teaching written over itself with our pipe here, into mutate, and then within mutate, we're using if else, case when, factor, if else again to create 1, 2, 3, 4 new variables. And that's essentially the answers to question 1 to 5. So this wouldn't be the way that you would do it in an assessment, because we're going to ask you to present these steps and the verifications one by one. But again, it's just to show you that with tidyverse, we can fit a lot of different things into one block of code. So I'm just going to run this. Oh, and I've got an error. Okay. So I've got an error here because I forgot to load tidyverse. So when we're saying it can't find this function, which is the pipe, I haven't loaded in tidyverse. So let's come back up here. And there we go, it's now attached. So let's run that again. Okay, so there we go, that worked that time. We can see it worked because we've gone up to 14 variables because we're creating 1, 2, 3 new variables and recoding a 4th. And if we want, we can run the checking interpretations here. But I'm mainly just going to move on to this part 2 on distributions. Okay, so let's look at these questions. So I'm just going to go back over to our actual question set. Now, these two questions are both very short and ask apparently the same thing, which is plot the distribution of a single variable and interpret the findings. Now, these kind of questions, they hide some complexities. So firstly, we know if we say plot, this is going to involve ggplot. So this is how we plot or graph out basically anything we do here. But we've got two different variables, politics and nat for est. So the first thing we want to do is look at what kind of variables these are. Now, in the case of politics, this is a survey question asking how much interest do you have in politics? And it's coded in these 5 categories, from 1 representing a great deal through to 5 representing none at all. So what we're dealing with here then is ordinal data. These are ordered categories. So each category is distinct, but it nonetheless encodes a sort of logical order. So a great deal is less than quite a lot. Some is more than quite a lot. Not very much is more than some, and none at all is on the end here. So for this then, we need to pick the right kind of plot. And for an ordered variable, the distribution is best shown by a bar graph. And in fact, we can only really graph this out with a bar graph because these are not, at least in theory, numeric data. In this case, nat for est, so what is this? It's called this because it's National Fraud Estimate. And it's a survey question that asks, out of every 100 people receiving benefits in Britain, how many have broken the law by giving false information to support their claim? So respondents can answer any number from 0 to 100. So 0 being no people out of 100 and 100 being everyone out of 100 people. They can also answer 999 or 998 for don't know or refused. But actually, we've already filtered those out. This is what this question 4 was about. So we just need to worry about how to plot a numeric variable with values from 0 to 100. And in this case, we're plotting this kind of variable. So in this case, it's a percentage or an estimated percentage. It could be a ratio or continuous data. The answer to this is going to be a histogram. So the way we plot the distribution is determined by the type of variable. So the type of variable is not in the question, but it is in the code book. So this is why we always need to refer to the code book and be very careful about how this data is coded in order to know how to answer a question like this. So let's come back to this and look at our examples. So here we've got BSA teaching. We've gone into ggplot after that with our pipe. We're using the variable politics. So we need geom bar. So these geom underscore options always tell us what kind of graph that we're using. And in this case, bar for bar graph. And we've got some color options here already built in. And actually, if we leave this blank, it'll still create a graph. But if we want to change the color, we can do it here. We've got a theme. We're just adding a minimal theme here. See, these lines are connected by these pluses. And some label options that just have placeholders in here. So if I run this, there we go. We can see we've got the distribution of the data here. Now, at this point, I've probably already got most of the marks for a question like this. So I've got a correct ggplot here that's creating a functional graph. And I can click on zoom here if I want to get this up. And I could right click to save image here. And, I wouldn't lose too many marks even with this. I mean, maybe it'd be a bit of an error to put add meaningful label here. But there's a lot of things we might want to improve about this graph. So in addition to adding these meaningful labels, and I'll do that in a second, we might also want a title. The more difficult question, or problem rather, to solve here is that we've got 1, 2, 3, 4, and 5 along the bottom here. And the reason why we've got this, if we come and look at our data set over here, is that politics is coded as the numbers here. So this is what our code book refers to. So these are how we should interpret this, but the actual variable is 1, 2, 3, 4, and 5. So we could interpret this graph by referring to our code book, but that's kind of an inferior way of doing it, because this is a bit counterintuitive. So even if I added my meaningful labels here, so if, for example, let's add a meaningful label to the x-axis. So I'm just going to take the politics variable here. So here's the question, and I'm going to use this for my x-axis label, and also for my source, I'm just going to add British Social Attitude Survey. So if I run this, there we go. Now, if I showed you this graph, sort of independent of any other information, you might assume that 5 is the highest category of interest in politics, it's the highest number, and 1 is the lowest. But that's actually not how this variable is coded. In fact, 1 is the highest level of interest in politics, and 5 is the lowest. And this is why when we're graphing out categories, we kind of want the actual labels to be what we see here. So how do we do this? Well, again, somewhat counterintuitively, we don't edit anything here in the ggplot. The solution we need is actually that we need to change this variable to have the correct labels. Because if I look at this variable, so I'm just going to use our class option here to extract politics and ask its class. This is an integer. But we know if we want to add labels, we've got this option. We can create this as a factor. And we can assign the right labels. So I'm going to do this. I'm going to come over to my common functions, and I'm going to try and find some ability to recode. So in this case, here we go. So we've got, this is my code for creating an ordered factor. So using my data and my data, mutate my variable names, and then I need to add these levels and labels. So I'm going to copy this out of here. Come back over to my lab 10 script. So I need to change my data placeholders to the correct ones. I need to change my variable placeholders to politics. And then what I need is, I need the correct levels. So the actual values here are 1, 2, 3, 4, and then I need to add another one, 5. And then the associated labels that I want with this are going to be poor, fair. Well, actually, no, they're not going to be these. So they're going to be 5 labels that I'm going to take from the variables. So I've got 5 different options here. So what's the easiest way to add these? Well, it's to come over to my data here. I'm going to copy these out. Come back over here. I'm going to add a hashtag to make sure this shows up as a note. And if I can't find this on my keyboard, I can have a, oh, let's come back to this, copy it again. So our first label should be a great deal for 1. Our second should be quite a lot. Third should be some. 4 is not very much. And 5 is none at all. So if I run this then, and here we go, we can see it's run down here. I could come over to my politics variable, and now what we're seeing is the labels. So I've assigned labels and levels to this politics variable. So now let's run this graph again. And now we can see we're getting our correct labels. Here it is. So we've now got a great deal through to none at all. Now, one interesting problem that we've created here is that we've now got missing values showing up. Because before, when we ran this, and if we come up here, we can see this. Can we see this on mine? I'm not sure we can. So this missing data was being filtered out before. This is actually a pretty easy fix, though, because we can add in another function in between our ggplot and our data. So by simply dropping the missing data from politics and then adding another pipe before ggplot, we take the data, we drop the missing data from politics, and then we ggplot. So the data flows through drop.na and into ggplot. We've now got a graph which is entirely properly formatted. So we've got rid of our missing data. We've graphed out the distribution. We've added labels, and we've added labels for each of the individual categories. Now, the only thing that would remain there then is that we've got to describe the distribution. And really here, all we've got to say is, what does this tell us about the data? So in this case, we can see the modal category is sum. So this is the individually largest category. The data is normally distributed. And there is a slight skew towards more interest in politics. Now, there's more we could add to that, but what we've got to do is just say sort of what this shows us about interest in politics. Okay, so let's move on to question 6. So this is the one using this variable that we know needs to be a histogram. So very little changes between here and here. So we change the variable name and we change this to histogram. And also, just for the sake of seeing the difference, we've also changed the fill color. But we didn't need to change that. So actually only 2 things, variable name and picking the graph type has changed here. So let's run this. Now here's our histogram. So again, we've got most of the marks already. If we can just remember to ggplot, to put in the data and to use the correct type of graph. So again, let's fix the easy stuff. So our x-axis here should probably be named for the question. So I just copied that straight out of here. So out of every 100 people, how many are estimating fraud in benefits? And our source is the same, British Latitude Survey. So let's run that again. There we go. And if we look at that in Zoom, here we go. And we can resize that a bit just so we can see it. And we could save or copy the image just by right-clicking. So there's a little bit less to fix here. But one thing you might notice is this is a bit of an ugly looking histogram because we've got these gaps in the data. Now, interestingly, we've got this for a sort of interesting survey design reason. So these gaps look like they're kind of 5 to 10 apart. And it turns out this happens in a lot of surveys. If you ask someone to estimate something, they have a rough idea of, but very few people have an intuition about precisely the number between 1 and 100. So very few people would guess to this 31, right? Exactly 31 people out of 100. So instead, people are jumping up in these gaps of 5 to 10 here. So people are likely to say 20, 25, 50, 55, 80, but very unlikely to say 83 or 61 as an answer. So this creates this slightly kind of gappy histogram, but we can always change how a histogram displays. So remember the fish tank analogy, where we can choose the number of different bars that we pour the data into. And we've got an option called bins here that allows us to change this. So I'm going to change that to 10 initially, just by adding in this option here. And here's my new graph. So I'm already showing that distribution a bit more cleanly. And how many of these you choose kind of depends on exactly what you're going to focus on. So here, my interpretation might be that, well, this is sort of normally distributed data with a strong skew to fewer people estimating, or more people estimating that there is less than 50% of benefit fraud. I might, though, say, well, what if we reduce this even more? So, I just accidentally deleted my code. Let's undo that. Okay, so let's change this to 3. So let's run that. Now, in this case, in some ways that might be more informative. So now I've got these 3 groups. So I've got a sort of large group in the lower range and in the middle range, and a small group in the upper range. So it might actually be easier for me to describe, what are my, what's the distribution of my data here? So if I said this, my analysis of the distribution, my interpretation would be something like most people estimate low or medium level of fraud, but a minority estimates very high levels of fraud. Now, just as we say the modal category for a bar graph, we might also calculate a few more things to help us describe the distribution here. So let's see if I can spell estimate correctly. Estimate. Medium. Got a little spell checker here in RStudio. I might want to put in a bit more data here. So just as mode is probably the correct average to describe a bar graph, the correct one here would be mean and median. So we have somewhere around kind of here, both the mean and median. But if I wanted to interpret this and describe it, I could just calculate this directly. So let's come back to my cheat sheet. And what have I got here? So I want to summarize multiple different calculations. And I've got this somewhere in here. So there we go, summarizing, grouping and summarizing. And I want to summarize the mean and median values of this individual variable. So I'm going to copy this. I'm going to come over here. Now, in this case, I don't need a group by option because it's just one variable. I need to change this to BSA teaching data. And the variable I want to use is, what is it, nat forest. And I want the median of this as well. And I don't need the count or the standard deviation, so let's just delete those two options. Making sure I've got the right number of, so I want to clear this out properly, so let's calculate those two. Okay, so I've got missing here, so that usually means that actually what I needed here was I need to drop my missing data so I can calculate these cleanly. So let's drop the missing data on this. We'll add a pipe. So we are dropping missing data and then summarizing the mean and the median. Okay, so my mean is 35.8 and my median is 30. Now this is always going to be the case. So if I've got data which is skewed in this way, my mean is always going to be greater than my median. So my median will be a bit lower, but my mean is being dragged higher by these outliers on the higher end. So I could say the variable has a mean of 35.8 and a median of 30, indicating a skew towards lower estimates of benefit fraud. So remember that you can calculate these additional numbers here, these additional estimates, if I want to just make sure that you know, the description I'm giving of this distribution is nice and specific. Okay, so the rest of this script then looks at various forms of bivariate analyses. So let's have a look at some of the questions on this. Now, bivariate analyses, all this means is so bi to variate analyses, right? So two variables going into our analyses. Now, there's a few ways that we could do this. So we can visualize and we can do cross tables and proportions tables. So in some ways, all of this is actually kind of stuff that we've done before, really. This is just stuff that the first assessment relates to. But what we've got to do is we've got to read this in the context of theories and then testing those theories. So I'm going to run through all of these, but bear in mind that the sort of underlying question here is pretty similar. So here we're being told, suppose we have a theory that those who consume news via social media are more likely to be politically engaged. So how can we test this? Well, what proportion of respondents who read social media news on a daily basis also pay a great deal of attention to politics? And then what does this tell us about our theory? And again, we have to interpret those findings. So if we're asking what proportion, and we've got reading social media news and paying a great deal of attention to politics, we're going to need a proportions table, and we're going to need to use the politics variable, and then also a variable that we created in stage 1, which is social media news, but we condensed these categories from 9 different categories into, I think, what did we do here? So we coded that into, yeah, just 4 categories. So yeah, SM News, 4 categories. So how do we do this? Well, again, we just do a proportions table of social media news. So here's our social media news. Here's politics. We're extracting them both from this data set. Again, we're working in base R. We're creating a table, and then we're converting it to a proportions table. So we're getting quite a lot of answers spit out here. And this is maybe sometimes when you look at this, it's a bit like, okay, what's my answer to my question? But let's just go back and read the question carefully. So what we want is, what proportion of respondents who read social media news daily also pay a great deal of attention to politics? So firstly, what we want is daily. Okay, so within this category, we're going to want the amount who pay a great deal of attention to politics. Now we've got this 2 on the end because this means we want to calculate within this category the respective proportions of a great deal, quite a lot, some, not very much, and none at all. So we just need to read a great deal and daily, and here's the convergence of those 2, and it's 0.288, so that's 29% roughly. So if we round that up, that's 29%. And are we being asked to, yeah, so we're just being asked about the proportion. So we could give this in a number of ways. We could give it as the raw number, but let's say it's 29%. Now, the difficult thing is, what does this tell us about this theory? Because now we need to say not just what proportion of respondents, but also what that means in relation to the other parts. So firstly, let's say in answer to this question, so let's go, the answer is 29%. What does this mean though? Well, we could compare it, for example, to these other examples here. So people who pay a great deal of attention to politics, if they use social media monthly or less, then only 4% of that category appear to pay a great deal of attention to politics. 57% appear to pay a great deal of attention to politics from the never category. And then the weekly category is again back to only 9.5. Now, this is maybe a little difficult to interpret because it means that within the never category, actually that's a large proportion of people who pay a great deal of attention to politics. But actually, that's maybe not that useful a way of telling us about the theory. So although we've been asked about the proportion of social media respondents who look daily at this and a great deal in politics, what we might actually want to do is let's look at within the other category. So let's look at within a great deal, what percentage show a great deal of attention to politics? Because actually what we'll learn here is that about 15% of people who read social media daily pay a great deal of attention to politics. But again, the second highest category here at 16.1% is never. So kind of what I'd say to this is that so people who use social media daily pay a larger amount of attention to politics than those who use it monthly or less. Actually weekly or less. Including monthly. Now the answer here is complex though, because part of the answer here as well, let's go on to another line for this. However, the greatest proportion of those paying a great amount of attention never use social media. So we get that from this table, right? So the greatest proportion of those paying a great deal of attention actually never use social media. But then the second highest category is daily. So it seems like what we're looking at here is sort of that we've got sort of two distinct groups. So we've got these people who never use social media, right? Maybe they're older, they read a newspaper, but they pay a lot of attention to social media, pay a lot of attention to politics rather. And then a different group of people who pay a lot of attention, but maybe it's because they use social media daily. So if we wanted to get really fancy with this, the data suggests no linear relationship. And that's because it's not the case that a larger amount of social media use leads to more attention to politics the greater the amount of social media use. It seems like that those who pay monthly or use social media monthly or less, or weekly, pay less attention to politics. But then those who use it daily pay a greater amount, and those who use it never also pay a greater amount. So it's quite a nuanced picture that emerges here, but it only emerges if we do this proportions table both ways round, because we want this answer initially, but then to investigate the deeper question, we need to switch the proportions table using this 1, so it goes down the column rather than across the row. So again, proportions tables are tricky, and the code is easy. The difficult thing is we need to think what the question's really asking us, and either select 1 or 2, or maybe to fully investigate that relationship, we need to look at both in order that we can make some meaningful statements like we do here. So the rest of these questions then more or less ask similar things. So we've got prop tables here, and also some visualizations using the scatter plots that we looked at towards the beginning of term. So I'll leave it there. If you want to investigate those topics, go back and look at the relevant week. But this again is just another example of how to work through some of these assessments, and again focusing here on how to visualize the distribution of variables and to create these interpretations.